What is Aurora Borealis? The Aurora Borealis, also known as the Northern Lights, is one of nature's most spectacular light shows. This breathtaking phenomenon lights up the night sky with glowing streaks of green, pink, red, and sometimes even purple and blue. These lights are most commonly seen in places close to the Arctic Circle, like Norway, Canada, Iceland, and Finland. But what causes this magical display? The science behind the Aurora Borealis is just as fascinating as the lights themselves. High up in the Earth's atmosphere, particles from the sun interact with the planet's magnetic field. When these solar particles collide with gases like oxygen and nitrogen, energy is released in the form of light. This creates the beautiful, dancing colors we see in the sky. The best time to witness the northern lights is during winter when the nights are long and dark. You need a clear sky and to be far away from city lights for the best view. In some cultures, the northern lights have special meanings and are thought to be a bridge to the heavens or the spirits of ancestors. Aurora Borealis is not just a feast for the eyes. It also inspires curiosity and awe about our planet and the universe. In this video, we'll explore everything from how these lights form to fun myths and where you can see them. Get ready to be amazed! How Aurora Borealis forms. The Aurora Borealis begins with a powerful force, the sun. The sun releases a stream of charged particles called solar wind, which travels across space at incredible speeds. When this solar wind reaches Earth, it collides with our planet's magnetic field, which acts like a shield, protecting us from harmful radiation. But this shield doesn't block all the particles. Instead, it funnels some of them toward the poles, both the North Pole and the South Pole. When these particles hit the gases in Earth's atmosphere, something magical happens. They transfer their energy to the gases, making them glow. The colors of the aurora depend on the type of gas involved. For example, oxygen creates green and red lights, while nitrogen produces blue and purple hues. The result is a mesmerizing dance of light across the sky, constantly shifting and changing shape. Auroras aren't just limited to Earth. Other planets with magnetic fields, like Jupiter and Saturn, also have their own auroras. Studying them helps scientists understand more about the interactions between solar wind and planetary atmospheres, making auroras not just beautiful, but scientifically important. Where and when to see the northern lights? The Aurora Borealis is most commonly seen in places near the Arctic Circle, such as Norway, Sweden, Finland, Iceland, Canada, and Alaska. These locations, known as the auroral zone, are prime spots because the magnetic activity is strongest near the poles. The best time to view the northern lights is during the winter months, from September to March. During this time, the nights are longer and darker, creating the perfect conditions for the lights to shine brightly. A clear, cloudless sky is essential, so weather plays an important role. Timing is everything. Auroras are most active during geomagnetic storms, which occur when the solar wind is particularly strong. You can track these storms using apps and websites that provide aurora forecasts. These tools tell you when and where the lights are most likely to appear. For the ultimate experience, avoid areas with city lights, as light pollution can make it harder to see the auroras. Instead, head to remote areas or national parks where the sky is dark and free from interference. Watching the northern lights in such tranquil environments adds to the magic of the experience. Myths and legends about the northern lights. The Aurora Borealis has fascinated humans for centuries, inspiring countless myths and legends in different cultures. For the Sami people of Scandinavia, the lights were believed to be the energy of souls or spirits dancing in the sky. It was said that whistling at the lights would summon them closer, which could bring bad luck. In Finnish mythology, the northern lights were thought to be caused by a magical Arctic fox running through the snow. As the fox's tail brushed against the ground, it sent sparks of light up into the sky, creating the auroras. This is why the lights are called revanchelit in Finnish, which translates to fox fires. In Inuit folklore, the lights were seen as spirits of ancestors playing a game with a walrus skull in the heavens. The movement of the lights symbolized the joy and energy of these spirits. Similarly, Some Native American tribes believe the auroras were campfires of their ancestors lighting up the night sky. Even today, the auroras inspire awe and wonder. Although science explains their origins, the myths and legends surrounding them add a touch of mystery and magic to this natural phenomenon. They remind us of the deep connection between human imagination and the natural world. The science behind Aurora Borealis colors. The northern lights display a stunning array of colors. But did you know that these colors are determined by the type of gas in Earth's atmosphere and the altitude at which the aurora occurs? The most common color, green, is produced when solar particles collide with oxygen molecules about 60 miles above the Earth. At higher altitudes, where oxygen is sparse, the aurora can appear red. This rare color is caused by solar particles interacting with oxygen much higher up, around 150 miles above the surface. Red auroras are usually fainter, but equally mesmerizing. Nitrogen, another gas in the atmosphere, contributes to shades of purple, blue, and pink. When solar particles hit nitrogen molecules, the interaction creates these less common but vibrant colors that make the aurora even more dynamic. The altitude and strength of the solar wind can also affect the brightness and variety of the auroras. During strong geomagnetic storms, you might see multiple colors blending together, creating an extraordinary light show that looks almost otherworldly. Understanding the science behind these colors makes the northern lights even more fascinating. They are not just random streaks of light, but a beautiful interplay between physics and the natural elements of Earth's atmosphere. How scientists study the northern lights. Scientists use advanced tools and technology to study the northern lights, helping us understand their formation and behavior. One of the most important tools is the all-sky camera, a special device that takes photos of the aurora from horizon to horizon. These cameras allow researchers to observe how the lights change and move over time. Satellites also play a crucial role in studying the auroras. They monitor solar activity and the Earth's magnetic field from space. These observations help scientists predict when and where auroras are likely to occur, providing valuable data for both researchers and aurora enthusiasts. Ground-based observatories in locations like Norway, Alaska, and Canada are equipped with spectrometers. These instruments analyze the light from the aurora to determine what gases are involved and at what altitude the interactions occur. This detailed analysis helps scientists confirm how different colors of the aurora are produced. Additionally, scientists use data from the International Space Station, ISS. Astronauts aboard the ISS often take stunning photos of the auroras from above, offering a unique perspective that shows the lights curving around the Earth. This view helps researchers understand how auroras form on a global scale. By combining all these tools, scientists continue to unravel the mysteries of the northern lights, turning this beautiful phenomenon into an exciting area of study that bridges physics, space science, and atmospheric research. How the aurora affects people and technology. The Aurora Borealis isn't just a beautiful sight. It can also impact people and technology in surprising ways. For example, strong geomagnetic storms, which create particularly vivid auroras, can disrupt power grids on Earth. This happens when charged particles from the sun create electrical currents that overload power systems, leading to outages in some areas. In addition, auroras can interfere with communication systems. Radio waves and GPS signals rely on satellites, but the charged particles that cause auroras can disrupt these signals. This can affect airplanes, ships, and even drivers using GPS for navigation. The northern lights also have an emotional and cultural impact. Many travelers visit aurora hotspots to witness this natural wonder, boosting tourism in countries like Iceland and Norway. For indigenous communities, the auroras hold deep spiritual and cultural significance, serving as a reminder of their connection to nature. Interestingly, while auroras can be challenging for technology, they also inspire innovation. Scientists and engineers study auroras to improve technology and better understand how to protect our systems during geomagnetic storms. For example, they develop advanced satellites and forecasting tools to predict space weather and minimize disruptions. The Aurora Borealis reminds us of the balance between beauty and power in nature. While it dazzles us with its lights, it also teaches us how to adapt and innovate in the face of its challenges. The future of aurora research. As technology advances, so does our understanding of the northern lights. In the future, scientists hope to study the aurora in even more detail by sending specialized probes and instruments into the atmosphere. These instruments could help uncover more about the particles involved in creating the auroras and how they interact with Earth's magnetic field. One exciting development in aurora research is the idea of using drones to study the auroras up close. These flying devices could capture real-time data from within the auroral displays, offering a new perspective on how the lights form and evolve. Drones might also help scientists observe auroras in remote, hard-to-reach areas where ground-based observations are difficult. Another area of research is the connection between solar activity and the strength of auroras. Scientists are working on improving space weather prediction models so they can better predict when the northern lights will be most visible. This would help people plan their trips and ensure they don't miss this breathtaking phenomenon. In addition to studying auroras, scientists are also exploring the potential benefits they might offer. Some researchers are investigating how aurora-related phenomena could improve communication systems and even help with understanding the Earth's climate. While these studies are still in the early stages, they could unlock new technologies in the future. Aurora research is an exciting field that connects space science, technology, and the natural world. As we continue to study these brilliant lights, we uncover not only the mysteries of the aurora itself, but also the amazing potential for future discoveries and innovations. How you can experience the northern lights. Experiencing the northern lights is a dream for many people, and it's possible to make that dream come true with the right preparation. The best time to see the auroras is during the winter months when the nights are longest and the skies are darkest. This is especially true in regions near the Arctic Circle, such as Norway, Sweden, Iceland, and Canada. If you want to see the northern lights, it's important to head to areas with clear, dark skies away from the city lights. Northern latitudes offer the best chances for seeing the auroras, especially places like Tromsø in Norway, Yellowknife in Canada, and Reykjavik in Iceland. These destinations are known for their aurora viewing tours and have many opportunities to experience the lights in their full glory. One of the most exciting ways to see the aurora is on a guided tour. Many travel companies offer trips where you can visit prime aurora spots, often including warm, cozy lodges or even overnight stays in glass igloos or ice hotels. This gives you the chance to relax and wait for the perfect moment when the aurora fills the sky above you. While the northern lights are difficult to predict, you can increase your chances of seeing them by monitoring aurora forecasts online. These tools show the likelihood of auroral activity based on solar wind and geomagnetic conditions. Remember to dress warmly, as temperatures in aurora viewing locations can drop significantly at night. Seeing the northern lights is an unforgettable experience that reminds us of the incredible beauty and wonder of nature. It's a moment where science, nature, and magic come together, making it a memory you'll cherish forever. Wrapping up our Aurora Borealis journey, the northern lights, or Aurora Borealis, are a spectacular natural phenomenon that continues to captivate and inspire people around the world. From their stunning colors to their mysterious origins, the aurora is a reminder of the wonders of the universe. It's not just a light show in the sky. It's a scientific marvel that connects the Earth, the Sun, and the magnetic fields, creating something truly magical. As we've learned, the northern lights are caused by solar particles colliding with Earth's atmosphere, creating an incredible light display. The different colors are the result of these particles interacting with gases like oxygen and nitrogen at various altitudes. The science behind the aurora is as beautiful and complex as the lights themselves, revealing the wonders of our planet and the universe beyond. If you ever get the chance to witness the Aurora Borealis in person, remember that you're not just seeing a natural light show, but experiencing the amazing forces at play in our atmosphere. It's a reminder of how much there is still to discover and explore, whether it's about the lights in the sky or the world around us. Thank you for joining me on this exciting adventure into the world of the Northern Lights. I hope this video has sparked your curiosity and inspired you to learn more about this incredible natural wonder. Don't forget to share this with your friends so they can also enjoy the magic of the Aurora Borealis. Until next time, keep exploring and stay curious.